Hello, all. Hope you all are keeping safe and washing your hands constantly. We would like to thank you all for joining us for this week's Saturday webinar on test automation for API and microservices. My name is Saurabh, and I'll be your host for today. Today's session will help you learn about how microservices testing is different. Uh, you'll also learn about different types of testing and the benefits about the same and how you can scale it on an enterprise level, right? Let me tell you about our today's speaker, Gaurav. Gaurav is part of Contentserv India, and he heads the QA automation team there. He's been working with product-based startups in the past and have been very instrumental in setting up overall quality and automation of web and mobile-based software products. Gaurav believes anything which is predictable, mundane, and repetitive should be automated, and only tasks which require cognitive intelligence should be dealt by humans. Bang on, Gaurav. I kind of think the same. So, great. And before we move on, I just want to give a quick shout out to our email partner, HandySense. HandySense are a trusted reseller of Twilio SendGrid in India. They help in delivering transactional and marketing emails through world's largest cloud-based email delivery platform. This is a platform which will empower you to communicate with your customers not only through email but also through other channels like SMS and WhatsApp. It is a well-secured platform with API key permissions and IP access management. And for everyone who's attending the webinar, and there's a free giveaway that HandySense is giving out. You can get 40,000 free emails for up to 2,000 contacts without any cost. If you're really interested in that, please send us a message and we'll help you on how you can redeem that offer. Uh, Today we have people from across the world. I mean, we have people from many countries. In fact, today we have people from India, of course, Philippines, Singapore, Malaysia. We even have European countries like Bosnia, Denmark, UK, and others, to name a few. And before I pass it on to Gaurav, I just wanted to give you a quick heads up on a few things to make sure that we all are on the same page. We will be shooting polls at timely intervals. This will be a yes no questions in between. It will last on your screen for 30 seconds, and we request you all to be very participative and engaging in that so that we can set context for the later slides for Gaurav. Second, if you have any questions during the webinar, please post all your questions under the chat section, and someone from our team will address it and make sure that it is answered by Gaurav. At any time, if you think there's a larger question or you want to talk to Gaurav or to us, just click on raise hand and we'll address your query right away there. There's a larger Q&A session that will be happening towards the end of the talk, which will last for 15 minutes. So if you have any major questions that that will need Gaurav's time in terms of explanation or understanding, then please keep a note of all the major questions, and we'll take those on during the Q&A session during the last. And I wouldn't take much of your time right now. This is all from me, and I'll pass it on to Gaurav. Gaurav, can you take over now?
Yes, thank you so much, Saurabh. Yes, I hope everybody can hear me out. Hello, everyone, and good evening, good morning, good afternoon, respectively, to folks who are joining from different time zones. I'm exactly not sure what's the time at your your location, but thank you so much for joining in here and showing interest in this topic. I would also like to thank Levin for giving me this opportunity and giving a fantastic introduction of mine. And I would also like to tell you that I have been working from past 13 years now in the field of software testing and automation. In last 5 to 6 years, I've been focused majorly around startups and the latest technologies and focusing more on the core benefits of automation. So automation is not just kind of focused on one or two tools or one or two types. It is a very, very broader preview, and it just doesn't focuses on test automation. Automations are on various levels, as we all know, DevOps, CI/CD. We are talking about site reliability engineering these days. So it's a larger gamut, which we kind of know and which we kind of hear every now and then. But today, specifically, we are going to talk about microservices. And microservices are something which we keep on hearing here and there, uh, and we get to hear a lot about microservices here and there. So what I'm going to talk about is predominantly microservices. Uh, and before I get started, I would also like to you know uh, just give you like a kind of feel to how we are going to proceed with this. How are we going to talk about this topic, what it is broken down into. Uh, so basically, today's session is going to be divided into three parts. We are first of all going to talk about what are microservices, why do we need it, how microservices are evolving and solving problems which are there uh, in the software development area. What are the kind of benefits? What is the value addition of microservices? The second part, essentially, we are going to talk about that now that we have spoken about what are microservices, why and how they actually work. We are going to talk about why testing microservice is different than the traditional manual and automation of monolith, as they say, monolith applications. And third, we're going to deep dive a little more on microservices tests. That what are microservices tests? Why do we need it? How do we go about it? And so on and so forth. So the first part is basically the what, why, and how of microservices. We're going to talk about definitions, the need of microservices, and also the benefits and application of microservices. So before we actually deep dive into it, I would like to take a quick poll before we go ahead, just so that we can warm things up a little. This is going to be yes and no question, and I'm going to just put in a question to you, and I just want you to just respond in yes and no. I think the question will the options will come on your chat box. Uh, so my question to you is just to understand what is kind of spread of audience we have for today. My question to you is how many of us are known to microservices? How many of us understand what is microservices? Okay, this is the question. I think there's going to be 30 seconds. Right, Saurabh? Yeah. So I would request you guys to just give me your honest answer on, are you aware of microservices? Or just a yes or no, just to understand that the kind of audience we have today, how many of them have a good idea or an okay idea about what microservices are?
So Gaurav, we have 49% audience saying yes and 51%
All right.
saying no.
Okay. Okay. Cool. Thank you, Sneha. Uh, all right. So it just started showing it to me. All right. Cool. So in the interest of those 51%, I'm going to dwell a little on what are microservices. Uh, I think I think we all have a little bit, or at some point of time of our career, we must have heard of object-oriented concepts, modularity. We must have heard of principles which talks about uh, keeping together things which are dependent on each other and isolating things which are not dependent on each other. We must have experienced how one particular line of code can bring down the whole application. Probably not today in today's day, but probably 5 to 6 years back. Uh, the problem with complex applications or bigger applications or a bigger anything which is big in size, like for example coronavirus is a big problem. So how are we trying to solve them? We are trying to solve them by isolating areas where there is more traction. We are trying to seal them. We are trying to look at uh, the problem by dissecting into smaller pieces and looking at individually. This is called modularity, modulation, or breaking down, or you can say divide and conquer. So this is essentially the theme of object orientation. Well, object orientation talks about building the software and applying those techniques on building the software itself, whether in terms of classes and in terms of methods and functions. Microservice is a similar technique which talks about breaking down your application into smaller services so that these services are independent of each other and they do not have much impact, adverse impact on each other. So it's a kind of a software development technique. It is a software development technique which also is coming from service-oriented architecture. So when we say software development technique, microservice architecture is influenced by that technique. And it's a kind of architecture pattern where smaller pieces of applications are sliced based on their business criticality, and these pieces are independent to have their own technical stack. So, for example, let's take an example of Uber or any taxi hailing app. Let's imagine that there are three modules. So there is one is login module for the customer, the user who wants to take a cab. One is the login module for the driver who is basically associated with this app. One is the view of customer to basically which detects its location and gives the availability of the cabs in that area, and the other is the reverse. These can be four different microservices. So when essentially the login of the user, the end user goes down, the login of the driver is still up and running and vice versa. It's not like because there is a login of one area which has gone down, we have to make changes in the code. We have to basically bring down the whole application and fix it and then deploy it back. So independent and disposable deployable units which are working in integration to bring a whole software solution in place. That is essentially microservices architecture. As I have mentioned over here on the slide, you can see that it is suitable for complex monolith applications. So at some point of time, if you have a successful software product, it will scale up to a limit, or it will become so big that your teams looking at their jobs from a project perspective won't be able to do justice to its stability and its maintainability. So it is better to carve out that project into a small microservice and give it to them, which essentially through an API gateways or through APIs kind of interacts with other microservices. And these two teams and these two services are independent of each other, although they might be loosely or tightly coupled. So, as I said, that these are the sum of the aspects, or these are the sum of the you can say part of definition for microservices. While having said that, I will also move towards why do we actually need microservices. Although I have loosely touch based on this as well. So I have also laid down some examples. So for example, Netflix, Amazon, eBay were on monolith, or you can say non-microservices based architecture at some point of time. And for example, a product like Netflix, which attributes to 30% of the overall internet traffic, you can understand that what kind of scale we're talking about. So even having just service-oriented architecture doesn't resolve the problem. It handles over 1 billion call per day, and from 800 different kind of devices. Like there are tablets, Android-based, iOS-based. There are television, smart televisions. Uh, there are mobile phones, both of Android and iOS, so on and so forth. And Amazon, we all know about Amazon. Originally they had the two-tier architecture, and then they migrated to service-oriented, and then hundreds of backend services, and then they eventually moved into microservices architecture. Uh, eBay. So why these big organizations, which were successful as well, why they kind of chose microservices? Of course, microservices is a smaller unit. It doesn't hold much complexity. They're loosely coupled. They can be taken out, fixed, and taken back. Imagine there is a pit stop in a Formula One race or a NASCAR race, how the team comes together and quickly deploys wheel changing, fuel refilling, and stuff, because every team has a modular approach towards their task. They're independent of each other, but they all come together and deliver the task in less possible way. Uh, this is essentially possible with microservices as well. Anything goes down, you can quickly decouple it, you can take it out, fix it, and deploy it back. You can do it continuously, and you can also quickly ramp up the copies of that microservice. That means that module can be copied, and it can be made up and running in no time. The dependencies of environment and configurations is reduced, complexity is reduced. So when we talk about testing environments, those dependencies cost can be controlled to a greater extent using microservices. Of course, it improves productivity and speed for the team, and makes the cross-functional teams autonomous of each other, and independent. And of course, if you have heard of what is site reliability engineering, then of course it is a suitable choice. So if you are implementing agile, lean, Kanban, safe agile, then microservices is a good software architecture technique, or good software development technique, which will complement all these changes in your organization. So it will be easier for you to implement automation on various levels. It will be easier for you to have a plan around site reliability engineering. It will be easier to have, or it is a mandatory to have DevOps, CI/CD, automation of your continuous integration and deployment. And the most interesting part is, which we have not spoken about till now. Uh, if your application is divided into various parts which are independent of each other, there is never going to be a bug or a defect on production which will bring the whole application down, or for which you have to bring the whole application down to fix it. Because if there are 5 microservices, you can take out one, fix it, and deploy it back. It is easier to roll back the code versions. It is easier to roll back the releases. It is easier to toggle a feature on and off on the microservices level. And that is why there will never be a situation where you have a priority one production breaking issue. And give it a thought that if that is the case, then do we really need a very elaborated integration testing on UI level, or regression for that matter? The answer to that is no. Second, if there are no P1 or production failures, issues, then do we really need manual testing? The answer to that is also no. We need manual testing, but not to a greater extent. We might just reduce it to 25%. I mean, if there is a successful implementation of microservices, but it takes time. I mean, it takes a couple of years to get there. So, but this is the point I wanted to underline. So you can have a lot of mundane, repetitive tasks to be taken care by machines while having microservices, because it demands higher degree of automation, not only from the test side, but also from the deployment, reliability, engineering standpoint. And after a successful implementation, the end result should be zero priority one issues. That means less dependency on QA or less uh, headache of maintaining those dev to QA ratios, and uh, a very wholehearted, elaborated test management systems. Although you need test management system, but not to a very greater scale of the traditional techniques which we have been hearing about. And of course, even if there is a production failure, there is a minimal or no production downtime, because you can take the service out, fix it, and put it back. While having said that, I would also like to tell you that it sounds fantastic, but it is difficult to kind of implement. It is not easy. When you start thinking of moving from monolith to microservices architecture, of course, you need to reverse engineer a lot of things. The ideal way, the ideal way to have a successful software product is that your software product should be very tightly coupled, or your feature set should be very tightly coupled with your business capabilities. Having said that, when you're slicing modules for microservices, it should be based on your business capabilities. So let's say that there is as I told you about an example of Uber, there are 4 or 5 different functionalities, major functionalities, and you will be slicing your microservices based on those functionalities. Login for driver, login for user, UI for user, accounting for driver, accounting for users, support issues, so on and so forth. So as I told you, slicing the modules based on business capabilities, then deciding on the service boundaries of these small services. They can be loosely coupled to each other, don't really have to be very tightly coupled. Deciding different tech stack, that's the fantastic capability or flexibility you have with microservices, that monolith applications usually, or polyglot applications, have different tech stacks. Monolith have a limited tech stack, but microservices can give you this flexibility that you can decide different tech stacks and databases, different programming languages and databases for each microservice. You can, and of course, you have to set up CI/CD. That has to be a way of life, and you can decide on exactly what is going to be abstraction for each microservice, and what is going to be exposure, what is going to be public through public APIs, and what is going to be abstracted, decentralization, and then deploying them. So I'm not going to basically give you a very deep dive into the implementation of microservices. Is giving you a high level understanding of it, so that you have an idea about it, and then going forward you exactly can deep dive well into a couple of links which I'm going to share by the end of this webinar. But you can see Hail is a Uber-like taxi, cab hailing application. It has around 450 microservices. Netflix has 500 plus microservices. Twitter has 500 plus microservices. So these images, let me just highlight this real quick for you. So these images are basically an interaction or a heat map when these microservices are talking to each other. In a technical term, or in a technical slang, I would say it is known as Death Star. Now, you can see how complex it can get, and understanding the mesh of all these microservices on an overall level is not easy. Of course, it's complex, and but all these microservices are talking to each other in a well orchestrated way to basically deliver a fantastic user experience at the end of the day. So I think Netflix is a part of everybody's life these days. And Twitter, for example, most of us, we use Twitter at least. So we all know that what kind of user experience we get, although there are hiccups here and there, but the scalability it provides and the benefits of maintenance and support it provides are also huge. So now that we have spoken about what, why, and how of microservices, let's talk about why microservice testing is different. So of course, as the architecture is different, the strategy, technique, and execution of testing is also going to be different for microservices. The test strategy, test technique, and execution are the three areas we're going to talk about here. So another poll time. I'm going to ask you one simple question. How many of us are aware of test pyramid? How many of us have heard of term test pyramid? How many of you have already heard about test pyramid? All right. So do we have, okay, cool. 59%, that's a good number. Around 60% of us have already heard of test pyramid and 41% have not. So I will ponder a little on the test pyramid piece. I will basically tell you exactly how this term test pyramid is becoming a new sensation in testing automation. Excuse me for that. So yeah. So if we want to basically envision the kind of testing ideally we should be doing, there are two types of testing. One is the business facing tests and one are the technology facing tests. Please pay attention to this. So when we say business facing tests, that basically these are basically coming from validation and verification. Business facing test basically focuses on that, are we building the right system? Is it what the user is looking for? This is the end user need or no? While technology facing tests focuses on, are we building the system right? Is it the right way of doing this? So the value addition which our product creates or any software product creates for an end user is a business facing test, and how technically or architecturally strong it is a technology facing test. Traditionally, all of these tests or all of these checks and verifications have been around UI or have been around black box testing or manual traditional sort of testing using different tools, test management techniques, testing techniques, so on and so forth. Testing techniques stands as it is, even with automation, there doesn't change. Testing strategy doesn't change much, but of course, your tools and your time to basically get results changes. So what exactly test pyramid tells you is that based on all these years we have been testing our applications on the UI level, regressions, integration level. All these years, we have, if we deep dive into our results, we will understand, and that's I'm generalizing this, but please pay attention to this, that Using integration and UI testing, the amount of issues you have found in your application, 85% of them, 65 to 85% of them will boil down to unit problems, unit cases, which could have been avoided if there were unit tests in place. 35 to 40% of them must be uh, uh, around integration or API layers if you're using API or whatever sort of communication pattern you are having. And very few would be an actual issue which should have been validated only and only on UI, like a spelling mistake, an icon here and there, misalignment of UI or something like that. But we all kind of test everything on UI level. That has been the traditional approach. So when people started realizing it, they understood that automating UI is a time consuming process. Basically, if you're using Selenium, you're automating the UI, you're putting regression to machines. It is just putting your manual efforts to the machines. You can run nightly builds. So what your engineer was doing in the morning, machine can do in the evening in non-productive hours, but it is not saving time. It is actually taking similar amount of time which a human resource used to take. And plus, most of the issues are still coming from unit level. So if you actually focus on unit testing as the major prerogative, you'll be able to reduce this. So once automation started coming into the picture, people started drilling deep into the root causes of the problems and automating them at that level. So that is why, if to sum it up all, test pyramids is a representation which talks about you should have majority of automated unit test cases for coverage standpoint. You should have integration tests, which can be automated API end-to-end test cases. They can be integration tests, they can be component, and in case of microservices, there can be contract tests. Then comes the automated GUI tests. And on top of it, there can still be a bit of manual exploratory testing. But different tests should be automated on their respective level. This on development level, this can be development plus QA, this can be QA. So it is a well-known thing that the cost of developing automation cases increases on this level. So majorly for most of the companies, this pyramid is inverse. We have automated GUI test cases as majority of test cases, then comes API, and the least are the unit tests. So automation pyramid basically advocates heavily to have majority of unit cases in the base of the pyramid, and then API cases, and then your GUI cases, automated GUI end-to-end cases, acceptance cases, and then on the top you have exploratory manual cases. It leads to a lot of benefits. Of course, faster execution, low on cost. You are getting benefit on time, you are getting benefit on money, and still high quality. UI regression, most of UI regression issues actually gets transformed into unit tests. It reduces infrastructure costs because you don't really have to run it on a separate environment. You don't need multiple environments. Of course, non-functional regressions, for example, security tests or performance tests, are not part of this pyramid. It reduces manual testing efforts greatly, exponentially, reduces overall resources by aligning the dev and testing goals together. And as I said, the only thing which ensures high quality in lesser cost and lesser time. So you know that golden three rule, right? High quality, cost, and time. You can choose only two. Here, high quality, and still you don't have to compromise with more time or more cost. So this is what we call the holy pyramid of test automation. But when we talk about microservices, as I spoke about, so every microservice can have their own tech stack. This is just an example of a multi-architecture polyglot system, and which kind of is which is kind of just give me a second. Yeah, so which is kind of bifurcated into different microservices. You can see microservice 1 has SQL Server database, microservice 3 has a MongoDB, microservice 9 has an event store database, 8 has Oracle, 4 has Postgre, 5 has Redis cache. And while microservice 1 is having ASP.NET, we have Nancy FX, which is a .NET Core technology for microservice 4. We have Python for 7, and we have Node.js for 6, and Golang for 12. Now, I have different tech stacks for different microservices. That means if I go about drawing my own test pyramid, how are we going to go about it? What is going to be my approach towards it? Plus, these microservices are going to talk to each other. So there's going to be heavy reliance on API testing. So that is why the topic is API and microservices testing, because there is no microservice testing without API. So I'm going to test a single unit, which is a microservice. There are components within that microservice which are talking to each other through API. Then microservices are talking to each other through API. So there is going to be a lot of traction on the API layer. That means integration tests and unit tests are going to be different for each microservices. So now coming from that pyramid to this pyramid. So now my pyramid has changed a little. Of course, the speed of execution is higher on the unit level and the cost of development is higher on the manual test level. But you can see that 70% unit and integration is changed. Integration layer, or this layer, is changed into 3 to 4 types of different tests. I have integration tests, which are API driven. I have consumer driven contract tests. We're going to talk about this in detail. I'm having system tests, if any. This depends on the application. This depends on the kind of product you are and what kind of system test you want to have. End-to-end API tests. And then comes the 10% layer, which talks about the UI tests. So heavy reliance on API tests, heavy reliance on unit test. These two layers essentially covers 90% of stuff. A little bit of exploratory testing. You can still live without UI testing to a greater extent, but that is not recommended, but to a greater extent. But you cover most of the stuff in these two layers. So integration is broken. End-to-end cases, which were part of the GUI tests, are broken into API as well as UI, and system tests are also integrated. So my test pyramid has changed a little in terms of API, in terms of microservices, because there is a heavy focus on API. So now we are going to deep dive into these tests, which are hinging around microservices, which are more focused on microservice implementation. So before we actually get into the various types of tests and various type of integrations, let's take a step back and exactly see what is a microservice. So
Gaurav, we also have questions that are coming in if you want to take that. Meanwhile, you can shoot some fun polls with the audience.
Okay.
Right. So we have 2 questions under the chat section. One is from Satish. Satish says, "Thank you for the wonderful talk on the API, but what should be the best API automation practice? BDD automation or test-driven automation?" While you answer that, I'll shoot some fun poll with the audiences.
Yeah, sure, Satish. I think valid question, and I would say As I told you, that test-driven automation is more towards challenging the technology part of things, I guess, and behavior-driven is more towards the business-facing part. Uh, of course, you cannot have the mixture of two when you're setting up an approach. I'm an advocate of test-driven automation. Uh, the reason being that no matter you have manual testers or automation testers, they should understand the behavior of end user or the business user. Uh, I would say test-driven automation or even test-driven development is the right way to do it. But different, one size doesn't fit all. Different software products have different user behaviors, different markets, different workflows, and different user stories. So eventually, it's a decision which needs to be taken along with architecture. I mean, the technology team, product management team, and QA team. But QA can be an advocate, which basically brings that to the table, saying that this is how this is the approach we should be taking. I hope I answered your question, but my heart lies in test-driven automation, to be honest.
Right. And the other question that we have, Gaurav, is from Siddharth, who is asking, what if your application is across multiple platforms, which I think you covered anyway, but still, if you want to take
I think Siddharth, you're trying to say multiple platforms as in web, mobile, and stuff like that, right? You can put it as a yes if I have understood your question correctly.
Yeah, I mean that came in the earlier part of the talk. So maybe.
Yeah. So I mean, yes. I mean, to answer your question very simply, it can be done. I have been working with such organizations where there are applications on Android, iOS, and web, and we could implement microservices everywhere. And it is possible, but you have to, for that, you have to, after this presentation, you have to deep dive into those applications, but it is possible to answer your question.
Right. Perfect. So I think we asked two fun questions to the people out there. I mean, at what time did they wake up was one of those. So we got 56% woke up before 8 a.m., which is interesting. 6% just woke up before the webinar. So yeah, but people are like still getting up on time is what, I mean, that haven't hampered the routine yet. The next question was how many attending in the night dresses. I mean, so we got 56%, 56% saying they are dressed up. I mean, not in the night dress maybe, but 44% of the audience which is okay. But anyway, everyone is up for learning, and that is a larger objective.
Yeah.
I think we should probably resume and get back to our topic.
Sure. Yeah, it says a lot. It says a lot that you're spending your weekend, you're investing time in learning. It says a lot about you, that what kind of priorities you have. So it's good to see so many people. 87 I can see active attendees right now. So congratulations to all of you. So let's proceed with the anatomy of a microservice. So this is a sample, or you can say an example of a microservice. So there are certain resources, protocols, repositories, data store or databases, some external services which are going to talk to this particular microservice. Of course, there are network boundaries, logical boundaries, and stuff like that. So you can easily say that this is a representation of a smaller software product itself, where we are talking about gateways, HTTP clients, domains, repositories, resources, etc. So if this is a microservice, just let me see what is happening here. Yeah. So how it works basically, if there are 3 or 4 microservices are there in a product, how do they work? So of course you can imagine that every microservice is isolated. Every microservice represents a service, and these services are talking to each other. So there is this service A, B, C, and they're all talking to each other, right? So having said that, when we talk about imagining or visualizing our unit tests, then of course we need to understand that unit tests are something which are going to happen or which are going to be relevant on the layers or on the components where we have written the actual code. So repositories, domains, service layers, resources, and gateways. These are the areas where my unit tests are going to be applicable. By definition, we all know what are unit tests. So unit tests are basically tests responsible for uh, testing the very basic functions of the code written, of the class or the methods with different permutation and combinations of input. Test techniques like equivalence partitioning, boundary value validations, uh, data integrations, data integrity checks can also be done on unit tests level, on this level basically. So you can put an invalid input, you can put a valid input. If there is an alphanumeric uh, input allowed on a field and you have written code for that, you can put like a non-alphanumeric, you can put special characters, you can put null values, space, whatever, and you can all do this on unit test level as well if you want to. So unit tests can bring in a lot of coverage. And of course, as I said, the test that verifies the behavior of class, methods, or functions inside a service, inside a microservice. So this is about the unit test which can be there for a microservice. And the next layer are integration tests. So what are integrations basically? Now that we have focused on certain tests on certain components of a microservice, integrations are essentially going to verify that if my microservice is talking to an external or internal database, so that internal database is talking to my data mappers through an internal API. Is this integration between the submodules of my microservice is working correctly or no? If there is an external service which talks to my microservice, is that integration with gateways and HTTP clients using API is there or no? So the test that verifies the external behavior of single service or an internal amongst the component as well. Again, these are heavily API based tests. And of course, as I said, then they use the external interface, service external interface to execute the business logic. And you don't really need to do negative testing here. Like you don't really have to put negative input. If you want to, you can put it, but the thing is that it is better to keep all that on unit testing so the maximum coverage goes down there, because they are easier to implement and they're easier to execute, and they're way faster than the test on API and UI level. So what you achieve in few hours of in UI, you can achieve in few seconds on unit level. That means less human resource, less expense on the machine level, electricity level, faster time to deployment, faster time to production, faster time to customer, more edge on the business side. So coming back to the integration tests, as I told you, positive scenarios are essentially the ones which you should cover in integration test. Understanding the core business functionalities and the core objective of the of the microservices are being tested and covered here. Then the whole microservice as a unit. So we have tested unit, we have tested components under that microservices, they are talking to each other or no. Then completely testing the whole microservice as a unit. In a microservice architecture, the components are basically the service themselves. So that means the whole microservice are being tested here. By writing test at this granularity, the contract of API is driven through test from the perspective of the consumer. So every microservice talks to a different microservice. It gives information, takes information. When it gives information, it is a provider. When it takes information, it is a consumer. Component tests basically understands and cover all those aspects which that particular microservice is entitled to do. Let's say that there is a microservice for login mechanism. So there will be unit tests where we should be able to cover that what is the maximum and minimum length for username and password. There can be integrations where forgot password links and all those things can be checked on integration level. There can be component tests where you can test everything else. Correct login application, with correct username password combination, it is working out or no. If there is a timeout session, it is going, it is considering that to bring the user to that page internally. If there are any such more combinations on username and password scenarios, you can essentially do it on the component test. You can automate it on API level. Of course, UI look and feel and the verbiage and actual placements of username and password field, the names has to be tested on the UI level, but the API related everything else can be done on the component level. So as I told you in the previous slide, that by combining unit integration and component test, we can achieve maximum coverage. I mean, mostly a very high coverage, and we can at least make sure that the microservices are working fine, and they are working within the prerogative of the right business logic. However, after this component test, there is another kind of interesting test which is called a contract test. Now, there is a very fine line between component test and contract test because there is a lot of confusion. There is a lot of confusion about what are contract tests and what are component tests. So we all know that components are nothing but microservices itself, and component test verifies the contract of the microservice. Then what are the different component tests? Contract test in that case. Now I gave you an example of a login mechanism, which is a microservice in itself. And we test the whole microservice, saying that that username, password, your forgot password link, and everything around the basic functionality of this module is working fine. But let's say that there is a scenario where we are implementing a single sign-on to this login module. I have an application where I can allow a Facebook login to work. So that means a person who is there registered on Facebook can also log into my application using the Facebook login functionality. I had my unit integration and component tests for my login module. But when there is an external integration happening with something like Facebook or Google, I have an understanding of the module. What is that understanding? The understanding is that your username and password can be utilized here. So if you have a user who's verified at the Facebook level as a valid user, I will let them into my application. This is the understanding between the two components now. Component of login at my end, and other hand we have Facebook. So there is an understanding, so that hence there is a contract that whenever there is a valid information coming from Facebook side, whenever there is a user who will say, yes, I have a Facebook login, clicks on it, I will redirect them to Facebook. Facebook will validate their username and password. If the credentials are valid, I will allow them in my application. This is the contract. So when the components involved, are microservices basically. The interface is the public API exposed by each service. So there has to be a public API, right? Which will basically help these two people talk to each other. And of course, writing these tests, not negative test, again, positive test, and few tests which validates the correctness of that contract are needed here. For example, there is a producer here. A producer is somebody who's giving the information, and this producer provides an information about a user. It provides an ID, name, and age. There are three consumers, A, B, and C. My contract with consumer A tells me I do not need age, I just need ID and name to work. I just need that much information. Contract B says, hey, I do not need name, I need ID and age. And C says, I need all three, ID, name, and age. So A was just wanting to have ID and name, B only ID and age, and C all three. We just need to test in these three contract tests that this contract is working fine. When I'm sending only ID and name, it's working fine. For A, for B, ID and age should work fine. And for C, any of these three missing, it should not work. So this is essentially is contract testing. Now, at contract testing level, integration level, component level, API testing is used heavily. You can have your own tool set, but there are specific tool set, like for example, pact.io, pact.io is a very well used, well received tool in the market for contract testing. Of course, when you're talking about interfaces, you're talking about when you're talking about microservices, a test environment cannot have all the microservices up and running. Every microservice have a separate team. They cannot, if we have 6 microservices, that means six different teams who are responsible for testing their own microservices. You cannot have 6 different testing environments. Of course, you need to have mocks and stubs. And when we say mocks and stubs, so basically you test contracts, you test integrations and components with mocks and stubs. And you keep only positive and valid business scenarios in mocks and stubs. You do not over engineer them. And that is a very essential reason of having most of it on the unit level. So what I'm trying to say is on unit and integration, again, you have covered most of the things. And you're having mocks and stubs to basically do most of the testing. But when you want to basically test the whole application with all the microservices working together, that is essentially an end-to-end test. Today, most of the companies having these end-to-end tests on the UI level, I'm talking on the API level. So you can see there are 3 services, 3 microservices, A, B, and C, all 3 talking to each other and sending an output here and here. Maybe this is an input, imagine this is an input. All the processing is happening here and there is an output from here. So all these end-to-end tests can be done on API as well as on GUI level. So if the system requires direct user manipulation, then of course UI is needed. Otherwise, it can be done on API level as well. Whatever can be covered on API should be part of the test strategy and the slicing, that what will go on API and what will go on the GUI level. So how it basically all comes together. Going back to the anatomy of a microservice, you can see that we started off with unit tests, which were there on public resources, service layer, domain, repository, gateways level. Then integration test, where the database was, internal database was actually talking to the data mappers within the microservices. Then we were talking about the component test, essentially the whole microservice itself, which was talking to an external service. Then we were talking about, or you can say the whole microservice itself was kind of tested, that what is the eventual output it was giving. And then we were talking about contract tests, the Facebook example which I gave you, and essentially talking to other services. An end-to-end test is essentially testing this microservice in tandem with other microservices and in collaboration with other microservices. So you can see that essentially a microservice architecture talks about emphasizing more on the granular level of the code written and moving upwards from there. Now, we have been talking about test pyramid, but one of the most essential things, and I give this reference to Amit Rawat, he tweeted this fantastic and very practical implementation, saying that when you are going through this implementation of microservices, it's not test pyramid, it's actually a pentagon. Every microservice have their own layer of unit, integration, and component tests. And every microservice talks to each other and verifies their contracts. So essentially, when you talk about the end-to-end test, essentially all these microservices are, touching base on the relevant tests, end-to-end user scenarios, which were not covered in unit, integration, component entirely, or contract entirely. And from a business perspective, basically you are having another layer of end-to-end API test. And on top of it, what cannot be validated on the API level and has the user intervention from GUI as a mandate, you put that into end-to-end UI journey test. And on top of it, you have very 5 to 10% of exploratory tests. Having said that, this is essentially all about, I wanted to give you an idea for microservices. The idea of this session was to give you a not very deep dive detailed understanding, but a very high level and yet clear understanding of how microservices are different, why they are being used, what is their buzz all about, and what are the different type of testing we are doing when we talk about microservices. Okay, quick poll, maybe Saurabh, if you can help me with it. Although I have not asked for it, but before, but this is the last slide, and I just want to check if every one of us have heard of Murphy's Law. And it's not the technical law. I mean, you can Google about it also. What is Murphy's Law? Have you heard of Murphy's Law? Can you just put a quick question, Saurabh, as an audience poll? Yeah.
Right. I mean, poll, I think won't be possible, but we can ask audiences to like quickly put a yes or no under the chat section, maybe.
No problem. Yeah. You can put it a yes or no. I mean, it's just a fun fact that Murphy's Law is. I'm a fan of Murphy's Law. So what Murphy's Law says is that
we're getting a mix
in a
of
nutshell,
yeses and no's. More of yeses here.
Yeah. So Murphy's Law is implemented on any task which you plan to do. Murphy's Law says that anything which can go wrong will go wrong. That means if you plan to do something and you can think of 5 things which can go wrong, be prepared that all these 5 can go wrong together and in parallel or one by one, but they all can go wrong. So plan accordingly. And whenever you're planning, of course, there are certain risks. And risk means they can happen. So Indian Air Force has this had this tagline which I like. They say that prepare for the best and be ready for the worst. And essentially that's how you should go about planning. So why I'm talking about Murphy's Law in Indian Air Force is that I wanted to show you this mind map of microservices. A mind map essentially tells you that a microservice have what are the different type of dependencies of putting a microservices as a practice or as an implementation in an organization. From a technical standpoint, of course, there is data, there are runtime things, there are design methods and UI and stuff like that. But from an organization standpoint, you can see that how many things are there. I mean, you have Conway's law. I mean, Conway's law talks about that the problems in your software product are essentially a reflection of the problems you have on the communication levels on your team. So if your teams are not very integrated, they will have tough time going microservices way. If they cannot go cross-functional, they do not have right communication patterns, there is a lot of isolation between the teams, they might not come together for the greater good of slicing and dicing everything. DevOps, if DevOps is not there, automation as a practice is not there, agile is not there, microservice is going to be a big pain for you. So essentially, as world is moving towards faster delivery, agile automation, whether it's on test side or on the site reliability side or on the CI/CD side, or from infrastructure and not your infrastructure side, and microservice implementation, they all go hand in hand. They all fulfill each other one way or the other. So you cannot have, you will not be able to get right benefits of agile if you do not have a faster software architecture pattern, which is less susceptible to problems and flexible and scalable and can be changed. So it needs an organizational mindset to basically bring in all these changes. So agile will not give you those kind of benefits. Test automation will not give you that kind of benefit. When people talk about replacing most of their tests with automation, that's not going to happen if you do not have DevOps, CI/CD, agile, or microservices. You will never focus on putting things into unit testing if you do not have a strong reliance on microservices. Monolith applications will not let you focus on these things. So automatically, microservices demands agile. They demands a better understanding of communication patterns, DevOps, and mindset to basically transform from an organization standpoint. So just to basically conclude my session, I wanted to basically show you this. And post this, I want to give you this small references to these two wonderful blogs by Martin Fowler. Martin Fowler is basically a person, I mean, most of us must have heard about him, that he writes a lot, and there is so much of meaningful information by him available on the internet. Please refer to these two links. One is regarding the practical implementation of test pyramid, and one is regarding the microservices itself, the snapshots and anatomy and the various kind of integration tests which I was talking about. I have taken those references from this blog. So yes, now the Q&A time. So
yeah,
I'm
well,
done. Take questions.
we have a lot of questions that have been flowing in. So I'll keep picking up few, right? So
Okay.
Rahul is asking, Rahul Dubey, is it good to have API automation on regression level, or it should be done on sanity level?
See, Rahul, we are not talking about regression at all here, to be honest. Regression only on unit level, only end-to-end cases on API level max. So gone are the days when there were regressions. As I told you that if you are working things on regression is a broader net to catch smaller fishes. Test pyramid implementation is the right bucket to get the right sized fishes all the time. So that there is a difference of techniques. So we have to get out of that mindset of regression and automating regression. It is about automating the right tests, ensuring right test coverage. You have a 7,000 or 15,000 or 20,000 test regression, but your actual meaningful tests out of them might be just few hundred which will cover 60 or 70% of your critical functionalities. So to answer your question, yes, it can be done, but that would be wrong.
Perfect.
Bring your
So
regression on unit level.
great, great. I hope Rahul that answers your question. We'll take a question from Meenal now, which is looks very fundamental in nature. It says basically how microservices are different than web services.
Yeah, so web services are basically a reflection of your message passing, right? Yeah, I mean, you have some parameters, request parameters, and it's a reflection of your API. That's it. And just exchanging of information. Microservices are not just that. Microservices are the smaller deployable whole software component itself. They have much more amount of programming. So imagine there is a software component uh, in your application which you test. There is a module, right? Imagine that module as a whole as a microservice. So there might be a ticketing module, there might be an orders module, there might be a requisition module, there might be a pricing module. Imagine that whole one module as one microservice. While web service is just like a path where you can exchange information through API.
Perfect. Perfect.
Yeah, that's about it.
Right. I'll take another question from Vikram, who asked loyalty program. You were talking about loyalty program, which can be an example of contract testing. Can you provide a few examples of couple of more examples of contract testing? And similar question from Sampad, who is asking
Loyalty program can be example of contract.
Yeah, what is the best tool for contract testing? Just an extension to the same question. The extension to the same question of contract testing is what tool?
So I would. Okay. So I think there are two tools which people are using. By the way, Saurabh, you guys can see my webcam, right? I mean, I'm just checking.
Yeah, we can see you.
Okay. All right. So there are two tools. One is pact.io, PACT.io. Another is which can be used for creating stubs is Mountbank, MOUNTEBANK, Mountbank. Although there are, it can be done in Rest Assured, and I think it can be done in Postman also. But I think you would need some paid capabilities of Postman, I feel. But look at contract testing only as a limited set of tests, not like very. I mean, what Vikram is asking is loyalty program can be an example of contract testing. I'm assuming that loyalty program is a module in the software. And which basically interface with some external APIs or external system. If loyalty program can be a microservice, there can be some essential use cases for which this microservices looks out to an external service. List down those essential use cases, 5, 6 very critical of them, positive test cases, and bring them to contract testing. And that is what I can, if I understand the question correctly, this is what I can tell you. Feel free to ping me on LinkedIn if you need more information. As in, if you really want to dwell more, and if I'm not able to understand this, you can also get my email ID and write it to me. There's no problem. Yeah, that's about it. Sorry. Yeah.
Okay, so Gaurav, the next question we have is from Sampath, and the question is, what is the best tool for contract testing and open source once referred?
Okay, so Sampath, as I told you, pact.io, of course, pact.io has a cost associated to it. I am trying to, I think Rest Assured can work. And also we are trying to do it in Karate DSL. It's an open source tool, Karate DSL. I think some capabilities can be mapped there. So you can check that out, Karate DSL. Very powerful tool and open source and getting stronger day by day. So that is something which you can check.
Okay.
Yeah.
All right. And the next question we have, Gaurav, is from Sai Dinesh. And the question is, are the managers ready to migrate to move to microservices testing? If yes, what are the best tools to do?
See, are the managers ready to migrate to move to microservices testing? See, microservice is a mindset, it's a decision which needs to be taken on the organization level. So when you implement agile or you go from monolith to microservices, uh, it's a decision which you take on the strategic level of the organization, saying that this is what we're going to do, because nothing is going to happen overnight and it is going to take a couple of years maybe once you start having the benefits of it. So managers are ready if organizations and executives on C levels are ready and they do see value in it and they see that their product is uh, valued enough in customers, and their main pain problem is stability or high quality or low quality is a problem right now, and stability and scalability is a challenge. So if these sort of problems are there, then you're an ideal candidate to go from monolith to microservices. And of course there is a cost associated with it, but once C level takes that decision based on the value addition of the product, its positioning in the market, then of course managers have to be ready. And there are no two ways about it. There are no tools to basically have this migration. It's a more of an it's more of a change on the architectural pattern on the code level, which involves Dockerization, going on cloud. List is long. So there are no tools which is okay. Now monolith goes over to microservices. So if I understand your question correctly, uh, for microservice service testing, there are tools. For example, for unit testing, if you Google about what are the best unit testing tools, JUnit, XUnit, there are n number based on the technology you're using. So those tools can be used for unit testing, whether you're in microservice or monolith. For API testing, for integration component, uh, and end-to-end, as I told you, for component and end-to-end integration, you can use Karate DSL, you can use Rest Assure, you can use pack.io for contract. And for UI testing, of course, it depends that what kind of UI you are having. I mean, can you use Selenium, or if you want to have a alternative to that, then there are so many good UI testing tools. Mabel is coming up, which is a self-healing, which does its maintenance automatically. Then you have Tricentis, and then there's Catalon. So these are the tools which you can use on the topmost level, on the UI level, UI automation level. So unit testing depends on what technology stack you're using. So please Google about it, that based on your technology stack what kind of. But yes, TestNG works, JUnit works most of the times. But you check it out what is suitable for your stack. So yeah, that's about it.
Yeah. Okay. Thanks, Gaurav. And the next question we have is from Josley. And the question is, how do you deal with hybrid architecture where is a mix of monolith and microservices? How will you
Oh,
strategize your testing?
yeah. So of course, at some point when you're moving from monolith to microservices, there's going to be a hybrid in place where you will have some, you know, you're going to be having this challenge that how will you strategize. Uh, the the pain point is going to be integration between the two. But if that is there in place, I think there is no way out. You have to keep these two things separate in the interest of time. But implementing a good testing pyramid is applicable both the ways. So I would say better to implement the test pyramid in non-microservice part as well. And then when you're going microservices, you push that pyramid towards microservices. Just make those changes in the API side. That's it. So there is nothing better than implementing a practical test pyramid, whether you are on the monolith side of things. It is quick to transform your testing abilities and testing strategy to microservices if the test pyramid is in place. I mean, that's what I can say. But it's a huge topic. I mean, to be honest, it requires uh, it requires a little more conversation than this. So I would have asked you a couple of questions that if you're talking about hybrid architecture, then how, to what extent it is hybrid, what are the points, and then I could have probably given you a little more specific answers. But on a high level, I would say testing pyramid is a common component, is a common thing, good thing, implement it, and then take it up from there.
Okay. So thank you, Gaurav, for this answering the question. So the next question which we have is from Vikram, and the question is all the microservices testing can be achievable in agile methodology.
Yes, the answer is yes. It can be achieved. As I told you, there are certain testing types which are not part of the pyramid, which are security testing, any non-functional testing basically. But all microservices testing can be achieved in Agile. Yes.
Okay, thank you. And the next question is from Pooja, which is with microservices architecture coming up, will there be a separate tester positions within DevOps teams?
Okay, good question. With microservice architecture, ideally, your team is cross-functional. And of course, DevOps and testing teams are part of one teams along with development. So your testing and development goals are tied together. There is one team which is consisting, which is cross-functional in nature. That means one team where developer, tester, and DevOps all are part of the same team. And testers are known as software development in test, software developers in test, SDETs. So
Okay.
this is the position which is being tossed around, basically.
Okay. And the next question is, what are the microservices testing tools, and are they different from API testing tool?
Not much, not much. To be honest, majority of microservice testing. I'm sorry, in my slide it was not. I have purposely not kept some examples of the tool because the examples of the tools, these tools are not generic. It's not like Selenium which will cut across most of it. These tools might vary on unit testing level based on the tech stack, as you said you have. For API testing, yes, Rest Assure can do the job, Karate DSL can do the job, Pack.io. These three tools will do the job for you most of the times.
Okay. So I'll just take the last question as we are running out of time, and the rest questions we can have it on, we can mail you, Gaurav. So
Yeah.
The last question which we have is microservices testing a good fit with waterfall development process?
Good question. Microservices are, if you're implementing test pyramid, you can do it on waterfall also, but your development phase should be merged together. So it can be done. It is not very straightforward, but it can be done. But I would not recommend that. There will be a lot of complexities. But yes, I mean, if you just focus on implementing test pyramid and keep it as it is, most of your testing will go to unit cases. Then unit testing has to be in practice. That can be done in a waterfall, no doubt. And testing phase will be shrinked. So in waterfall, how it happens is that so your testing phase will only have some API testing to be done, some exploratory, and some UI automation. But at the same time, in waterfall model, we usually talk about bigger chunks of software development. It creates a lot of problems. So you can do that. It won't be successful. It won't last for few months. You will see people fighting with each other, to be honest.
All right. So so actually we have a lot of questions coming in. However, we will take it later. So let's wind this webinar. So thank you so much, Gaurav, for a wonderful session. And we are already getting a lot of great comments over for this session. So it was a pleasure listening to you. And thanks for taking out your time for this day, for today. And I would also like to thank you. And I would also like to thank all the attendees for attending and taking time out on a Saturday. And before winding up this webinar, so I would like to thank our email partner, HandySense, and they have a very good offer for all the attendees who are here. So they are giving free 40,000 emails from their site. So if you can sign up with the link, you can avail this offer. So you will get the link and all the details for the video and the YouTube link over the mail. So thank you, everyone. Have a great weekend.
Thank you. Thank you,
Thanks,
everybody.
Gaurav. Thank
Thanks.
you.
Bye-bye.
Bye-bye.